So I'm Andrew Morris. I'm with a company called Chemical Concepts. I'm here presenting this course, Adhesives and Sign Fabrication for the ISA. A little bit about me. I've been in the adhesive business for 12 years. I've been working with Chemical Concepts. I'm a family member in, got touched the mic. I'm a family member in that business, so I've been at this a long time. And I'm a third generation person who's been worked around glue. I'm a third generation glue guy, as I like to say. So I say I'm not a chemist, but I play one on TV. So I've worked around sign shops for a long time. I've been outside reps consulting with companies, consulting with sign companies, with installers, working outside the sign industry, whether it's a car, a truck, a bus, a sign, a piece of electronics, whatever the case may be. We deal with product assembly, and that's my background. So when people are trying to join two things together, I work with engineers, work with manufacturers, try and help them figure out the best adhesive solution for what they're trying to do. We learn information about the application. What are you trying to do? And then we figure out, okay, here's the requirements, here's the application requirements, here's the process requirements, how fast do we want to work, how do we go, walk me through what you're trying to do, walk me through how your process is, and we work backwards from all that information, try and figure out, get you the best thing to make you successful. So that's kind of my background. I won't pretend to be a sign expert welcome everybody. So if you guys ask questions, you might throw some curveballs at me. I could probably give you an answer in terms of what's the best. I can answer the adhesive part of the question. If you ask me very specific, okay, what's the best adhesive for a push-through letter, for a reverse channel letter, for a regular channel letter, I might have answers for that. I might be able to defer, so just fair warning. I won't own being an adhesive expert. Still don't know everything. There's way more, there's more information about adhesives than can fill the ocean, but I know a little bit, enough to be dangerous, as we say. So that's a little bit about me. I know you guys probably come from all over the place. We talked about that a little. We got people here from Puerto Rico. We got people here from Seattle. So you guys came a long way. Want to make this valuable for you. So we'll start off with that, which is, what are some questions, and we'll just take a few, not to burn any more time, but what are a couple questions that you'd like to learn through this presentation? Anybody? Yes?
So I know a sign shop in LA that uses 3M adhesive.
Okay.
No welding. Put these cabinets together and ship them out. So I wanted to see if that holds up.
Okay. So is using tape a good option to replace welding? Okay, we'll touch on that. Anything else? Any other burning questions you hope to get to? Paint department.
Explain when stuff comes back fabricated, too much glue on it that causes the prep time to decrease. So what technique fabricators use to be?
How can we be neat and clean, not use too much excess? Okay. All right, I'll take one more, and there'll probably be time for more questions, but I just want to preload some. Yep, yes, sir.
Gonna be a good replacement.
Good replacement for trim cap glue. Yeah, we'll talk about that. You guys got some communications about methylene chloride? Yep, we'll touch on that. Good replacements for trim cap. All right, so I want to get you guys involved. We did that a little bit. Where'd my clicker go? Here's my clicker. So we're going to continue to get you guys involved. So this is another question. This is a live survey. So you can pull out your phones. You can scan that QR code. And I'm trying to get a sense of the room. You know, everybody's on a spectrum from, what this gentleman described. We just tape everything. We don't do any welding. It's all in the end. We've fully embraced adhesives. Oh, you know what? I don't trust it. We don't use it. Somewhere in the middle, everyone's somewhere on that spectrum. So this should live update. This thing's supposed to be pretty cool. We're going to test drive this thing. So the question is, how do adhesives fit into your shop? Let's see if this is live updating now. Did anybody successfully complete it? All right, any adhesive embracers here? Anyone say, you know what, we use adhesives all the time. We love it. It works awesome for us. Yep, we got one right there. Anybody else, would you say you're, fully embracing adhesives, or at least further on that end of the spectrum? Do we have any, I hate to use the word haters, do we have any anti-adhesive people? Who doesn't trust it? Okay, we got somebody, that's okay. We get a big tent here, we can include a lot of people, a lot of viewpoints. All right, so we got a nice mix. So 42% of us, and this will probably update, maybe this will change. Maybe the people that don't like adhesives are a little slower on the technology, so it's taking them a little bit longer to fill out the survey. So maybe that's hurting us a little bit. Oh, okay, here we go. All right, special projects. But still, you could talk about the prevalence of adhesives in the sign industry, and so this is a testament to that. If we were to do the same survey 30 years ago, 20 years ago, 15 years ago, how do you think these numbers would change? So clearly the sign industry has evolved. Adhesives have become, that's the first question. Why are we here? Why are we talking about this? Why are you guys here? Adhesives have become an indispensable part of the sign industry, and 42% of us are saying they're an essential tool. So if we're gonna have an essential tool, we wanna learn how to use it just like any tool. You guys are professionals. We all wanna be, aspire to be at the top of our craft, and this is one tool in the toolbox, we gotta know how to use it. So why adhesives? So 43% of you think that adhesives are essential, and obviously you get some benefit from using them. And let's just talk about what those, maybe you understand them implicitly, but do you understand that explicitly? Let's clarify some of the reasons. So let's talk about adhesives versus welding. So depending on the application, adhesives can be as strong or stronger than welding. And what that means is, it doesn't mean that if I do 12 inches of weld, continuous weld, and I did 12 inches of continuous adhesive, and I just pull those apart and measure the force it took to pull those apart, it doesn't necessarily mean that the adhesive is going to win that contest. But you have to look at how welding is used in practice. Often we're competing, when I say we, I mean the adhesive industry writ large, we're competing with spot welds. And so one of the things that adhesives can do is they can spread the load over a larger area. When you have spot welds, you're typically doing pinpoint spot welds, hence the word spot, and that is stress concentration. So you're loading up all of the load that's being applied when the wind comes, or if it's a machine pulling these apart, all that load gets concentrated on pieces of metal. The metal starts to deform in those areas, they become weak points, cracks propagate, and then you have a failure. So when you compare, let's say, 12 inches of spot weld to 12 inches of continuous adhesive with a 2-inch overlap joint, and if you have an adhesive that's, say, 2,000 PSI multiplied by the surface area by a 2-inch by 12-inch strip, now you got a lot of force. You got a lot of force capacity. So as stronger, stronger, we can join mixed materials. I'm sure there's a lot of really good welders in this room. I'm not an expert on welding whatsoever. I do know it's challenging to weld mixed materials together. So certain times, there's MIG welding, there's TIG welding, so I don't really understand any of that. But I do know that if you're trying to weld different materials together, that can pose challenges. So if you're trying to do aluminum to stainless, aluminum to copper, aluminum to brass, whatever the case may be, you might have some issues with welding that. Adhesives can solve that problem. Maybe you've got pre-finished materials. I see a lot of pre-finished materials in the sign industry. Yeah, don't be shy, find a chair anywhere. You won't bother me. I see some empty chair up here, empty chair over there. Find your place, no problem. So if you have pre-finished metal, why are you gonna spend money on mirror finished stainless or brushed aluminum only to distort that with a weld and then have to pay a guy to sand it again? So that's one of the reasons we look at adhesives. Sometimes you've got duplicate steps. With adhesives, you can bond and seal in one step. I could put an adhesive on let's say I could do spot welds and have to come in with a silicone or a sealant. With an adhesive, we can eliminate the step. And then we talked about material deformation. That's one of the risks associated with welding. When you weld, that creates heat-affected zones in the material, especially in metal. I don't know, and not everybody knows this, but when you weld metal, the material around that metal can reduce the total strength of that metal in that area. So heat-affected zones don't return to the full strength that they had before they were superheated. So that's one area. And then also they could just create aesthetic issues. And then post-work. So, you're paying one guy to weld a bunch of stuff, you're paying another guy to hide all the welds. So if we can eliminate those rework steps, we're winning. So this is, now we're going to some specific information, aesthetics. I believe I'll call out, we did a picture submission contest. Hey, send us pictures of stuff that you've done with our products. I believe that's from Philadelphia Sign. I should give credit on that one. There's a little picture from Lord Corporation too. If you see that picture on the bottom of rivets versus a clean adhesive joint, and you can see the corrosion around those rivets. That's something I didn't mention either. I've been talking about welding so far. We're also replacing other conventional fastening methods, such as rivets and conventional fasteners. Anytime you drill a hole in something, that's a point for water ingress, that's a point for corrosion. If you have some kind of protective coating on there, that's an opportunity for that corrosion to spread. So that's another example. So you can eliminate the exposed fasteners, you can eliminate weld and distortion marks, and you can keep using your pre-finished materials without having to rework them. You guys all have these packets here. Feel free to try to give you make this a little bit interactive, that you're not just sitting here absorbing. So if you go over the answers to those questions, we're eliminating fasteners and weld marks. You can, well, we got to that first one. So here we are, dissimilar materials. So there was a question about clear adhesives earlier for metal to plastic. That's an example of what a joint like that might look like. So when we're bonding mixed materials, that's something you can't do with a weld. That's something that's often difficult to do with mechanical fasteners. That's something that's difficult to do with mechanical fasteners and maintain the aesthetics that we want on our projects, the aesthetics that our customers demand, right? So we can join materials where fasteners or welding are not practical. So that second one, dissimilar materials. Can you bond adhesives, metal? Can you bond metals, plastics, masonry, or all the above and more? What do you guys think? So save time. So here's a nice graphical representation. When you're busy, time doesn't move the same. If I'm running around all day, I'm at work, I'm taking calls, whatever, man, those 8 hours fly. So sometimes people are sitting there, they glue something, they're waiting for the glue to dry, and they go, man, this is taking forever. Like that was 15 minutes. But you're sitting, compare that to what you're doing when you're welding and you're grinding and you're brushing and you're doing your welds and whatever. But when you actually have someone that's not yourself stand back and time you, what we see time and time again is time savings this is a comparison of welding, riveting, riveting with an automatic machine and adhesives, the total labor and the total time invested, especially it's kind of hard to see, it's a little bit small, but post-processing is where you save a lot of time, and actually the process of applying the adhesive is where you save a lot of time. Now let's talk about lightweighting. So that's another application. So often when you're welding, you're using thicker metal than you need to. You're using a certain thickness of metal that's required in order to get a good weld. And you don't want that. We talked about rework and distortion and all that kind of stuff. So we're trying to avoid that. So when you use adhesives, you can save material costs. You can use lighter, you can down gauge your metals. You can save on the metal costs. You can create lighter weight signs that don't require as much force and as much risk hanging on the building. So we can reduce. This is I'll credit, ITW Plexus. They're saying up to 35% lower mass on the total assembly, which is, across a wide variety of applications, but that's just kind of a standard. So I could go on and on about this point where this is, again, like a 101, an overview. So I just did a deeper dive. Yeah, come on in if you want to see. So why adhesives? We talk about aesthetics, dissimilar materials, time savings, post-process elimination, lightweighting, material savings. We talk about labor savings. We talk about this one. It depends on who I have in the room. Some people in the room might not be a fan of this one. If you guys are a welder, you might be saying, wait, hold on a second. That labor you're saving, that's my time. But it frees you up to do the stuff that has to be welded. And not everything has to be welded. Welding definitely has a place in the sign shop. Welding will never go away from sign shops, but let's weld the things that have to be welded. And then we can use our time more efficiently. If there's sign shop owners in the room, maybe this is more of an interesting point that we can train anyone to use an adhesive, and it just frees up our labor challenges here where, okay, I can get my best welder. He can weld the really tough stuff where I need that level of skill. Maybe this guy is young, he's not as good, he's just out of trade school, his welds are just okay. Let's give him the glue gun and send him off to the races. So labor savings and then performance. So that's enough of just like the why adhesives. Let me just stop there. Any questions or comments on what we've heard so far? Again, this is a interactive. Want your participation. Anything? Bueller? Okay. So adhesives 101. So let's talk a little bit about the types of adhesives that you'll find typically in the sign industry. This is an abridged list. There's probably many more. These guys are working around the clock like there's a cure for cancer of new adhesives coming out every day. There's thousands of adhesives on the market. It's kind of overwhelming. That's probably one of the reasons why some of you guys are here. So let's talk about structural adhesives. Structural adhesives are very common. There's a lot of non-structural adhesives in the sign industry, but we're going to spend a fair amount of time focusing on that. And most of what I've already talked about is kind of related to structural adhesives. So within structural adhesives, there are three main chemistries. There are acrylics or methyl methacrylates. There's also acrylates. We'll talk about that. But I would include that in the acrylic family. There's epoxy, and there's two-component urethanes. So a lot of you guys, what's probably most prevalent in the sign industry is acrylic or MMA adhesives. Acrylic or MMA adhesives have really quickly risen, let's say over the last 20 years in popularity, overtaking epoxies and some of the older technologies. Two-component structural urethanes do have applications in the sign market. There's just fewer of them. And the reason is because two-component urethanes do not adhere to bare metal well. And as you guys know, there's a lot of bare metal being bonded and being used in the sign industry. Two-component urethanes have advantages, and they do bond prepared metals if you have pre-finished metals. So there is a place for those. We'll talk about that. So and we'll talk about the pros and cons. A lot of people just use the word epoxy. They use it interchangeably. They just use it like the term Kleenex. Oh, I'm going to epoxy that. You know, if you're using a lot of really common products in the industry, Lord, Signlock 406, Plexus AO 420, Adhesive Systems MP55 420, some of the 3M DP 805, Well Done 30, Well Done 45, any of these products out there, those are all MMA adhesives. And so a lot of you guys are probably using one of those. And so that's what a lot of you guys are familiar with. And when we contrast, good.
Sorry, you said MMA. So is that an acrylic?
Oh, yeah. So I'm using the term acrylic and MMA interchangeably. So MMA stands for methyl methacrylate. And so it's short-term acrylic. So
That's where Lord would fall.
well, Lord has all three of those technologies.
For example, on most side guys do Lord 406.
Yeah, so 406 is a dominant, that would be an acrylic, right? And so the older technology is epoxy. Epoxies are very strong, they're very chemically resistant. They do tend to be somewhat brittle, and they do bond metals, but they require a lot of surface preparation. So the substrates have to be totally clean, they have to be really well abraded, it's gonna take you a lot of prep steps. And the acrylic adhesives, or MMAs, have really overtaken in that if you were to do a line chart of adhesive uses by chemistry over time, you see this really big growth pattern for MMAs, and they've been adopted because they are almost surface prep free. So you just do a solvent wipe, make sure your parts are clean, glue them together. If there's a little bit of surface oils on the thing, the methacrylic acid in the product will insert, for some products more so than others, will cut into that. So still prep is an important step, but it's more minimal. The other thing that's really important is the cure curve. So epoxies tend to cure in a linear curve. So when epoxy is 80% cured, when it's 80% through the cure time, it's about 80% cured. A lot of acrylics on the market use what's called snap cure technology, which means that within an hour or two, you're at 90%. So instead of that curve looking like this, it looks like this. And that's advantageous for you guys, because when do you need strength? You need strength right away. You don't need strength tomorrow. You want to be able to bond your parts and move them on to the next step in the operation. So that's another reason why acrylics have become so popular. And there's still applications for epoxy. For instance, epoxies like to bond will bond porous substrates better, more readily. Acrylics like non-porous surfaces. So acrylics don't work well. So we talked about Lord 406, some of those other glues that I rattled off, they don't bond wood so well. They don't bond masonry so well. So that's when you're looking at those kinds of materials, let's say sign foam, HDU. When you're bonding those kinds of materials, that's when you might want an epoxy or a urethane that's going to bond with more porosity, okay? So that's a little bit on structural adhesives. I can go on and on, but we'll talk about tapes. So a lot of high bond tapes. So you might be familiar with 3M VHB, or there's a lot of alternatives on the market. There's Chemset VST, there's Tessa ACX Plus. So these are a variety of brands having that kind of acrylic core tape technology. That's very popular. When you compare that and contrast it to liquid adhesives, you have instant bond. So you put those two things together, it's on there. And it's not at 100%, but you do have some instant grab. Those adhesive tapes will continue to wet out, and you might hear me use that term, wet out. What's happening is that those tapes have some elasticity to it, and there's micro cracks in the metal. And you could think of that elastic adhesive as having like almost tentacles, like an octopus, and it's slowly flowing into all those micro cracks. So typically over, let's say 3 days, you'll get to say 90% strength, and it can take up to weeks for those high bond tapes to get to full strength. Also important to know, just for you guys that are working with these tapes, they are pressure sensitive tapes, which means, and in fact, I had somebody come up to our booth yesterday and we had a roll of tape, and they took two pieces together, took our tape and pulled it apart. They said, "Oh, that didn't work so good." So the tape is only on there insofar as you apply enough pressure to force those little tentacles into those micro imperfections in the surface. So I said, no, let's do another test. So I took 2 pieces of metal. I didn't have a roller. Typically, you would use a roller or some kind of thing to apply your force to the surfaces. Really put a lot of force, let it hold on there. Really roughed up both sides in terms of just putting my weight on it and hand it to him again. Okay, let it sit for a minute, had a conversation. Now try and pull on it. Oh, that's totally different. So when we see failures with double-sided tapes, there are bad batches, there are production issues. That stuff does happen. It is very rare. Most of the reputable manufacturers that I listed have very good quality control. So unfortunately, maybe you guys don't like to hear this. Sometimes I'm the bearer of bad news, but 90% of the time when we see failures, there is some we find through the course, there is some application error. And in the case of tapes, it's the number one offender is insufficient pressure. It's on the data sheet of the tape. A lot of people don't read the data sheets. That's fine. I don't expect you to. But your supplier should be able to tell you what amount of pressure. Just ask the question, how much pressure should we be, it's right on the data sheet. You need to apply X amount of pound force per square inch to get this tape to reach its maximum performance. And how long does it need to be clamped? How long to reach full strength, et cetera, et cetera. So then there's just, let's say, double-coated foam tapes. So these are similar. They're double-sided. They're very, well, they work well, but just a totally different ballpark in terms of maximum strength. That's when you see the words high bond, right? That's in a different echelon, a different category. The foam tapes are like hanging an interior wayfinding sign. I don't need to hit a light bulb with a sledgehammer. Use the right tool for the job. They're more economical. They work. You could use them in conjunction with a sealant. And that's another thing we can talk about is just using combinations of things. And that's where tapes really come into play for me. Using a belt and suspenders, can you apply a tape around the perimeter of a panel and secure it in the middle with a liquid adhesive? You get the best of both worlds. You get that instant grab from a tape. You get the structural, because a tape, even the best tapes are not going to be in the same ballpark as liquid adhesives. Liquid adhesives will give you your highest ultimate strength in terms of adhesive technology out there. So now let's talk about sealants. So that's similar performance at the end as tapes. And sealants, very popular as silicone. I think, there's some open chairs. Feel free to find a spot. There's some open chairs up front here. There's some up front here. Don't be shy. So silicone, I find, is really overused in the sign industry. I feel like a lot of sign companies are using silicone in applications where silicone might not be the right fit for the job. That's my personal opinion. And because silicone is more of a sealant, it's not really an adhesive. There's a spectrum, right? So you got 100% adhesive, 100% sealant, and all these products fall somewhere in there. So silicone has some adhesive ability, but 90% of the time when I see sign guys using silicones, they're using it really as an adhesive, and I think there's better products for that. And especially because any of you guys that have paint shops know that silicone can be a dirty word. Silicone does not play nice with paint. It does not play nice with other adhesive. It does not play nice with tapes. I had a sign company come by our booth yesterday and said our standard practice is to put high bond tape from one of these major brands along with a silicone. If any of that silicone gets on any of that tape's dead. That part of the tape is dead. You've got that, nothing sticks to silicone, including the adhesive on the tapes. So there's MS polymer products. MS polymers are more adhesives. There's construction adhesives. There's polyurethane, one component sealers, one component construction type adhesives. There's better products out there that are more of an adhesive. And the guys in the paint shop will prefer you using it. But for certain applications, silicone does make sense. And then solvent-based adhesives, we'll talk about that. Those are very prevalent these are almost not really an adhesive. It's a solvent. It's actually melting and softening and breaking apart the polymer chains in the plastic and allowing them to refuse together. So it's really melting the plastic together. I guess it's functioning like an adhesive. There's a lot going on. Maybe you guys have seen some communications about what's going on in the world of the EPA with methylene chloride. We'll touch on that. And then contact cements I see, and there's super glues, UVs, thread lockers, a million other technologies. So there's not a lot of information there. We'll kind of fly over that just for the purposes of time. So I talked already a lot about high bond tapes. I probably won't. Here's just a little bit. So we talked about acrylic core technology, high strength, they're fast application. The clear products are very clear. If you want high clarity, I think that's where tapes kind of have the liquid adhesives beat. There's not a lot of really great, super clear liquid adhesives. It's just a problem. But the super clear tapes look awesome. They're not repositionable. So with adhesive, you have some some flexibility. I can put it on. Oh no, that's a little bit crooked. I can mess with it with adhesive, with tapes. You got one shot. You put that tape on. If you take it off and try and use it again, you might be asking yourself for trouble. You want to peel that tape off and start over again. So you just got to be really on it in terms of making sure that your position is dead on. That requires pressure. If you have a static load and something that's really heavy, those tapes will work. They'll stay bonded, but you can have something called creep where that sign could actually just be slowly climbing down the wall and just has a certain maximum load. If you exceed that maximum load, you can see creep. So that's where combinations are good. The adhesives can give you that belt and suspenders, that initial grab, and the liquid adhesive is more chemically bonding, because when you have a tape bond, that's not a chemical bond, that's a mechanical bond. That's those tentacles of the adhesives grabbing into the surface, and you apply enough load to that, that can creep. So, one of the questions I think you asked me that is, can you just tape things together and ship them out the door? You can, but it's all about what is the application going to see. If there's a high static load, maybe you want to tape and an adhesive, or tape and a weld, or tape and a fastener. Something to consider. That's ultimately up to you guys. And that's, the final point there. I already talked about that. We'll breeze through this, but generally there's the direct foam or the coated direct foam are the most common tapes you'll see. There's also the transparent adhesives, which are similar to the direct foam, but they're clear. So we'll breeze past that. Silicone. We talked about where silicone is used. It's a one-component product. A lot of uses. You guys are all familiar with it. You use it in your house. Urethanes, there's a lot of urethane-based construction adhesives on the market, typically one component. Those have isocyanates in them, which are some kind of health hazard. They're not really dangerous per se, but some people do react to isocyanates. They also don't play as well with paints. So then you start seeing hybrid. You might go to the hardware store, you might go to your supplier, you might buy something that says the word hybrid. Typically that means MS polymer. You could think of it kind of like a modified silicone. So that has really a lot of the advantages of urethanes. I don't really see urethanes, as my personal opinion, having a huge place in the sign industry. I think you'd be better off with an MS polymer. You get all the advantages of urethanes. Plus you can paint them. A lot of times you can paint them when they're still wet, which is nice. With a urethane, you have to let that dry completely. You can literally take a MS polymer, put it on a joint, and then spray it before it's even cured, and it won't interfere with the paint. And you get as strong or stronger than silicone, depending on the material. I'm speaking in generalities here. So those are the three main families. There's solvent-based, one-part construction adhesives. I'm not a big fan of those. They shrink and crack. They're not 100% solids. You have a question?
Yeah, RTV, what family?
So RTV means room temperature vulcanization, which is silicone. So RTV was that first category. So all one-component silicones are RTV. Good.
So we use silicone.
Okay.
I got, penetration.
Oh, yeah.
I mean, you told me that there's a better product than could we, when we do like acrylic,
Yep.
aluminum lighter, double-sided kit, double-sided kit. I signed it together with silicone.
Yep. Yeah. I think you'd just be better off. I don't think you'd gain. I don't think you'd lose anything. I think you'd gain. And that's just, that's, again, so it plays nicer with paint. It plays nicer with tapes. You get higher strength, and it's an adhesive. So silicone is great if you have a bathtub and you want to put that on there and you want to make sure that your bathtub doesn't leak. I think you're asking the product to do something it's not really designed to do. Now, there are quote-unquote structural silicones, but those are super expensive, and you still look at the performance. I don't see why you would choose that if you lay out all the information over an MS polymer.
So like a GECS 1000.
Mm-hmm. So I can't say I'm familiar with that particular product. If it's CS, maybe it's like contractor sealant or something like that. So again, it's a sealant. So I would use something that says it's an adhesive. Also, some of the MS polymers have what's called instant grab. So silicone, so similar to what I talked about with the urethanes, some of the MS polymers, you can put them on the wall and they will almost hold, it's called green strength. It's not cured, but it just will hold right there. I could put two bricks on a wall, one with an instant grab MS polymer and one with the silicone, and the silicone is just going to fall right down the wall. The MS polymer is going to stay there. It almost gives you a third hand on installation. So you could put that up there. You could put a couple of daubs of epoxy and an instant grab MS polymer, and it's going to, if it's a lightweight sign, it's just going to stay there, and it's going to stay there while the adhesive cures. And there's another, anyway, that's a great option to me. Instant grab is a nice feature you can't get with a silicone. Yes, sir.
What's the price point there?
If you get a high quality, like there's cheap silicones on the market that are maybe low quality. If you get like a name brand, like a GE or any of those kind, or a Sika or something like that, you're going to be maybe a buck more. So if you're at like $5-6 a tube of silicone, you mean for a good MS polymer, you might be 7, 8, 9. There's some really good MS polymers that are maybe like 10 or 12. But still, at the end of the day, when you think about how much adhesive do you have in that sign, you know, whether it's $6 or $12, okay, I've doubled the cost of my sealant. But what percentage of the cost of my sign did I increase? You know, there's maybe 25 cents of adhesive on that sign instead of, you know, versus 50 cents instead of 25, or $1 instead of 25. At the end of the day, does that matter? And when we have things overhead, then we don't want things to fall down, you know, where can we save money? You know, I would argue that maybe adhesives isn't one of the places to look, that if our goal is to have our name out there. Anyway, that's my soap, getting off the soapbox for a minute. So any other sealant questions? Yes, sir.
What's the removability can?
For sealants?
Yes, sealant available.
So what the question was, how difficult are silicones to remove or sealants to remove, and is there a big difference from one to the other? So I would say the difficulty of sealants to remove is related to the hardness of the sealant. So hardness is measured with durometer. So it could be a 60 Shore, it could be a 35 Shore, it could be a 20 Shore, and we compare that to things like a pencil eraser or a tire or, you know, a piece of steel. So the way they measure that, there's a sharp object and it goes, how far can I dig into it? You can do it with your fingernail. I mean, you can't measure it accurately, but you get the idea of what I'm saying. So a higher durometer sealant is going to be more difficult to remove, but I think they're all relatively, and there's not a huge range. You might be between 30 and 60, really, really hard sealant. So you get a high durometer MS polymer, it might be 60 Duro, that's 60 Shore, that's pretty hard, but typically 35. So you're gonna be similar to a silicone, and I think a good way to remove that is like piano wire. So if you could just get a thin wire and just kind of cut the bond and then mechanically scrape if you need to. For my money, I think it's pretty much any of these, I can pretty much remove them the same way like that. You know, also like the oscillating multi-tools are great for those kinds of things if you can do it really carefully. They have like the oscillating multi-tool blades that are like a scraper instead of like a blade, so it doesn't really damage the material depending on how much you're trying to salvage the part. Good question. So solvent-based, I talked a little bit about that, not too much to add there. There's different viscosities, they could be thick, they could be thin, and they do contain flammable or toxic solvents. The EPA is moving forward with a ban on methylene chloride. There was a comment period that ended, I believe, at the end of 2023. In the notifications they've been sending out, they said there's going to be some action. This was said at the end of 2023. They said some action was going to happen in 2024. So here we are in April. It is 2024. If you take the EPA at their word, then sometime this year we might not be able to get methylene chloride. However, they have not come forward yet with a firm date. So that means you still have some time. It's something that's on the horizon. It's not something that's tomorrow. So if you like those kinds of products, you might want to get some inventory because it might be while supplies last. The EPA could punt and just say, you know what, 2025, me personally, I can't predict the future, but the likelihood, in my personal opinion, I don't think it's likely that here we are in April that the government doesn't move that fast. You know, they're not going to turn that battleship and get something done by the end of this calendar year. I find it hard to believe. But some manufacturers are taking proactive steps. We had one of our suppliers that uses methylene chloride-based contact cements that said April 1st, we're done. And we're like, whoa, and they gave us like 2 weeks notice. So those kinds of things are happening, and there's no predicting what individual manufacturers will do because they're worried about compliance. They're worried about their perception in the industry. Do we want to sell toxic stuff? Do we want to sell stuff that the EPA has its radar on? Do we want to do this in an orderly way and just get out now rather than scramble at the end? So that's going to be a lot of individual decisions. So you got to think about that, something to be on your radar. All right, so now let's talk about best practices. This is really important stuff. So like I said, same with tape, same with adhesives. Bad things do happen in manufacturing, but 9 times out of 10, there's some kind of operator error. And you guys can arm yourselves, arm your people with the best practices to make sure that you don't have an unfortunate event happen to you where the adhesives don't work the way that they're supposed to. And I would encourage you, reach out to your suppliers, see if they can come in, do a lunch and learn. The guys like pizza, they like learning, you like making sure that stuff goes right. So take them up on that. Are they willing to do it? Find a supplier that is willing to do it. They should. If they want to sell you glue, they should help you use it right. Don't you think? So simple stuff for using cartridges. This is credit Parker Lord. This is, I'm blatantly stealing some material, but that's okay because it's all the same stuff and I got permission, so we're good. But clean the bond areas. And so this is, I'll go into detail. So first you clean, then you prep, and then you make your parts and clap. Sounds simple, right? So how do you clean? So first we do a dry wipe, then we do a solvent wipe, then we abrade, and in a perfect world, then we solvent wipe again. Because after we abrade, we create dust. We want to do a solvent wipe and clean that dust off. You can't stick to dust. You can stick to dust, but you're sticking to the dust. You're not sticking to your product. And you guys probably instinctively understand that to be true. If you've got a dusty surface, the adhesive cures, you'll pull that up. You don't have good contact with your surface. So that's one of the common things that goes wrong. Now, we're talking about mostly for two-part cartridges here. That's what's dominant in the sign industry. So if I just grab a tube, so the first thing we're going to do is level the plungers. So in the case, I'll just pick this cartridge just for all the cartridges are a little bit different. You might be asking yourself, oh my God, why are there so many different kinds of cartridges? Why are there so many different types of tips? We could talk about that. There unfortunately are reasons for some of that. So with this particular kind of cartridge, a lot of them are different. This one has a retaining nut. I'm going to remove that retaining nut. This red cap just comes right off with it. And then I do have the gun that goes with this particular cartridge. Unfortunately, all the different cartridges have their own guns, and some of them are interchangeable and some of them aren't. Don't you guys love it? So we just slide that into our cartridge, slide our cartridge into our dispenser. We got some cardboard here. And then I'm just going to, this is called purging or leveling the plungers. So what I'm doing here, so if I don't do this, what you might be tempted to, what some of you guys, some people in this room might do this, is just put the tip right on and start gluing. And what could happen there, and let's see what happens. Because, well, here's a bad example, because this cartridge, and this is the exception, not the rule, this cartridge right off of the gate had equal amounts of A and B coming out. I almost never see that. I glue stuff together almost every day. And typically I have 3 inches or an inch of the A side coming out before the B side. If that happens, and I can probably grab another tube off this table and get that to happen. But if that happens, now I got like 6, 12, however many inches of adhesive coming out of that mixer that's got no activator. If I'm off ratio, I can't expect a good bond. So this is insurance that both parts are together, both parts are present in the mixer, and both parts are mixing, okay? So that's the big, big, big thing. Then I got the mixing tip. There's different mixing tips. I might get in trouble for this, but there's different mixing tips that will work. The mixer that is included with the cartridge, if that's not your preferred mixer, talk to your supplier, ask them, I want a longer tip, or I want a shorter tip, or that still works. And if they can't tell you that answer, maybe find a supplier that can answer that question. But here's one. So you can put this mixing tip on, and it should be suited for your application. And now I'm going to dispense some adhesive. I'm going to do basically a mixer length. This is probably a big mixer length. I was moving fast, but that's waste. So it takes a little bit for the adhesive coming out, and so that's another step that is often skipped. So one of the earliest technologies was anchor bolts, where epoxies were used, and they found every 50 anchors, one was not working, because in construction, sometimes they positively test. There's some regulation. I'm going to put anchor bolts in concrete, and I'm going to test every 50th one, or I'm going to test every 5 or whatever. And they're finding, why? What's going on? Every 50th bolt is failing. And they found out that every 50th, that's the number of every time when they're switching cartridges. So they'd switch cartridges, and the first 2 bolts didn't work. And so that was a painful lesson for people in that industry that has since been hopefully learned. So that's what I just went through. Level the plungers, check the mix ratio, dispense the adhesive, and then this is waste, but maybe I want to do a reference bead. I love this idea. Just do a little bit of a bead, keep it on a piece of cardboard. Every time you open up a new piece of glue, a new tube of glue, get a Sharpie, write down the lot number and the time that you did it. If you got a sign glued together and you can't see the adhesive, you can't check to make sure it glued up properly. If this little bead cured, that gives you some assurance that the adhesive in the sign cured. So that's a nice QC step that you can easily implement into your shop and give you some assurance that if there's a issue with the glue, I'm gonna know about it on the cardboard before I know about it on the sign. So something to think about. Here's my clicker. Yep, and you can see, this is an example of what I was talking about. So you can see the color. So you want a uniform mix. If you see 3 beads and 1 bead's a different color, that's telling you that something's wrong. That's a yellow, that's a red flag is what that is. Then you gotta mate and clamp your parts. There's different times. What's the set time of this adhesive? That's a question I get all the time. What's the set time of this adhesive? Well, that question has a lot of answers. Are we talking about the working time? Are we talking about the handling time? Are we talking about full cure? So there's typically 3 numbers that we talk about in the adhesive industry in terms of timing: working time, handling time, and full cure. And those names might go slightly different names. It might be fixture time, it might be handling time, it might be pot life. So that's what makes it extra confusing for you guys, because you're hearing these different terms. But when someone throws a time, you have to translate in your head, what do they mean? So the working time, that's the first, or open time, or pot life, that's how long do I have to get my parts together. If I'm using, we talked about SignLock 406, if I'm using SignLock 406, or I'm using MP55 420, or I'm using AO 420, or I'm using 3M whatever, I gotta know what my working time on that product is, and let's say it's 6 minutes, which is at 70 degrees, mind you. So if you're in Palm Beach, you're in the summer, guess what? That's it cut in half probably. So if you got 6 minutes and you take 10 minutes to get your parts and clamp them, you're not getting the full strength. And what a lot of people don't know is that a lot of these adhesives are available in different speeds where you get the same ultimate performance. So ask if there's a slower version of the adhesive that you're using. What a lot of sign shops do is they use the slow version in the summer and the fast version in the winter, and they kind of stabilize their cure times. A nice little rule of thumb is for every 20 degrees you go down or up, you're doubling or halving your working time. And that's not exact, but it's a guideline, it's a rule of thumb. So if you're 20 degrees down from 70, if you're at 50 degrees, you've probably just doubled your open time. Factor on that. And then you got a certain amount to clamp, and then that next time is the fixture time. So that's the amount of time that you have to clamp your parts and move them on to the next step. Generally defined as, I believe it's somewhere, different adhesive manufacturers will use their own terms, but between 100 and 1,000 PSI. So enough to do whatever you got to do. Move it around. It's not going to fall apart. I wouldn't bang on it with a hammer, but you've got some strengths. Any questions on this part here?
We make reverse letters.
Yep.
Rotate. And after we mess with it.
Yep.
The way that we shoot a reflective primer on the letters, even in the light.
Before it's fully cured?
Well, that's my question. And we're not sometimes we're getting these days shooting it, green, move, sand, prep into a cut fade out. So does it need 24 hours to cure his warriors?
All right, I'm gonna phone a friend. What do you think, Gail?
Oh.
Yeah, so you're saying no, he can do that. Yeah, so that's a chemical reaction. We've got 2 parts mixing together. That chemical reaction is taking place whether or not it's exposed to air. In fact, Lord 406 is an anaerobic adhesive, meaning it's going to cure better in the absence of air. Sometimes you feel that surface tack that forms on the top. Anyone ever feel that or know what that is? What that is that the oxygen is coming in contact with the adhesive and preventing that very top layer from curing. The adhesive underneath that top layer is totally fine, but the air actually inhibits that reaction, and you end up with a little film that just comes right off with a solvent wipe. So you hear from the Lord person in the back, that's an acceptable practice. Then another thing is just joint design. So a lot of people, you don't do butt joints with an adhesive. Adhesives are all about surface area. So if you're typically doing something like this, does that mean you can't glue it? No, you might have to just change your design a little bit. So can we change, so here's the do's and don'ts, right? So if I do this, let's say this is a butt joint, can I change a butt joint and turn it into an overlap joint? And basically, each version on each side of this chart that's in your packet is a better version of the do, is a better version of the don't. So anytime you see the joint designs in your work, can you change it to that variant and you'll have better performance? And it's just the nature of adhesives. Adhesives are strong in tensile. Adhesives are strong in shear. They are weak in peel. So if you want to make an adhesive break, so if I have 2 parts bonded together, if I want to peel it, like peeling a piece of paper with that kind of force, that's where, so if you can change the design to eliminate the peel loads, reduce the peel loads, increase the shear and tensile loads, That's where you're going to have more success. Okay, so I already did a little bit of gluing. We can do a little bit of freeform. We can glue things together. We can talk about dispensing a little bit, but I think everyone wants to see this, so maybe let's start with this. So what I have here is a little pull tester, and we're gonna do some of this live, and we're just gonna see what kind of numbers that we get, and maybe you guys would find that cool, because I think, again, you don't wanna just sit here and watch me yammer on all day. So this is what we call this kind of test. So this is a machine, and it's got a digital reader right here, and I'm gonna turn this crank, and it's gonna apply force to this disc that's bonded to this piece of metal, and we're gonna see what kind of results we get, and then maybe we'll talk about what we see. So this is called the dolly adhesion test. So we've got our piece of metal, we've got a metal dolly, we've glued this on, we've let it sit over 24 hours, and now I've got one actually loaded up right here in the machine already, and let's just do it. So I'm gonna start cranking here. So we've reached, this is in kilonewtons. So I believe a kilonewton is 225 pounds per kilonewton. So I'm gonna have to do some live math to tell you where we're at. If anyone wants to take a calculator, I'm gonna throw numbers out and tell me where we're at. So I am at, let me just make sure everything's set right, everything looks good. We are now at 1.8, 1.92. So we're around 400, 450 pounds, something like that. We're gonna keep going here. We are at 2.7, 3. 3.5, 3.6. Here I'm gonna model good behavior here. I'm gonna put on my safety glasses. All right, we are at 4. So we were at what? We were at 400 pounds, so now we're at roughly 800 or 900 pounds, right? We are at 5. What's 5 times 225? And we're gonna hear a loud pop, don't be scared. It might sound not like a gunshot, but we're at 5.3. And I'm turning the crank and I'm not seeing the numbers go up anymore. So I'm thinking that pretty soon, I'm gonna see this pop off. Oh, no, 5.8. Whew. See, I scared myself. You guys are tougher than me. You guys aren't scared, I'm scared. All right, so we got to 5.9. I'm not gonna put my expensive machine right in my glue that I just put together. Okay. So what I'm gonna do is pass that around so we can look at it. Let's see, let's just try a couple of different glues. So here's the dolly, here's the piece. You can just kind of take that, pass it around. And while that's going on, let's do another one. So here's a different glue from a different manufacturer. I won't name names, but we'll just see how different the numbers are. And maybe what we'll learn is that not all glues are created equal. They might look similar.
So the first one was that acrylic?
Yeah. So we're doing metal to metal. Acrylics are our go-to for metal to metal. So almost, I think everything I have here are all MMAs. So let's do another one. So I got another product lined up. I'm gonna get my pull tester. I'm gonna put my dolly on. And I'm gonna turn my crank all the way back down. And you know what, while I'm doing this too, so I got this hooked up here. I got some other things to just pass around, just stuff to give you ideas about joint designs. So this is tape, and this is a tape that can actually handle powder coating. So this side is powder coated. This side is a tape that will bond to powder coat, which is a hard to bond material. So we'll just pass this piece around. These are called surface mounted fasteners. I don't know if you guys have ever seen this kind of technology. These ones are glued, these ones are taped. So we'll just pass different bonded parts around. Let's get hands on, let's look at things, let's touch things. Here's just some metal. I'll just start at different places. Here's some aluminum bonded together with a structural adhesive. This is HDPE, high density polyethylene. If anybody has ever worked, probably not a lot of that used in the sign industry, but it's really hard to stick to. This is a special process. You have to corona or flame treat the product, and there's special adhesives that will stick to this without flame treatment. So that's what you see here. So this is an example. Let me give this side a little up for the guys in the back not waiting around forever for stuff to come back to them. What else do I got in my bag of tricks? So here's like a channel letter example bonded with a clear adhesive, with a somewhat clear adhesive, we'll say. Give this to you, you can kind of pass that around. So it's got a little bit of color to it, but it's more clear than other products on the market. All right, so we got to 5.9. So let's try and remember that number. And 5.9 was what again? Who did that math? 1,300. What do you think? Is that impressive? Is that not impressive? Did you think it was going to get to that? Were you thinking more or less? All right, so now I'm reset my meter. And I'm going to try and do this one a little bit faster now that I have some idea of where we might end. So I'm just going to keep cranking now. Oh, geez. So that one got to 3.4. So 2 different structural adhesives, 2 different numbers. And one is about half of the other. That's interesting. Let's do a different one. Let's do this one here. Let's just do one more. And then we can do a stud weld. How does that sound? We can do that next. Any other requests for the hands-on portion of this demo? Does anyone want to try anything themselves? Does anyone want to try dispensing? Does anyone want me to go over the best practices with them, make sure they're doing everything right? All right, so let's do one more test like this, then we'll do the stud weld. So what was that number? That was 3.4. What was that? Who's my math person? 760. Respectable number. Okay, so I got this one loaded up. We got our reader reset. Back to 0. Let's see what this one does. So 3 different MMAs, we're gonna have 3 different numbers. And I wonder if me going faster on the second one resulted in a different number, I'm not sure. So we're already at 2.5, 2.6. Oh, I'm turning and the number's not changing. That tells me we probably got failure soon. Oh. Look at that. So that one got to 2.6. So far our winner is at 11, we said 13 something? 11? I've got a bad memory of that already. All right, now let's do a stud weld. Let's see if we're in the ballpark or not. So let me put this down. Here's my stud welds. Where is this thing? Oh, here it is. All right, I'm going to reset my machine. I might need to reset the legs. Let's see. And I can kind of multitask here. But you know what? So how are we doing on time? We are at 1:54. We got a couple minutes left. While I'm prepping this, I'd like to invite, is Mark still back there? Mark, step out. Okay.
Did I?
Yes, I can multitask.
To glass.
Yes. So glass is a tricky material, and glass sweats, which means you might look like you have a good bond initially, but over time, you might not get the strength that you think you're getting. So with glass, we typically need to use a primer. There's different glass primers on the market. Find a glass primer from one of these structural adhesive companies. I know one off the top of my head is Lord AP134. So the Lord AP134 is going to give you that bondable surface. And then I would recommend, did you say metal to glass?
Yeah.
Then I would recommend an MMA adhesive like we've been talking about. So MMAs will bond glass, but it needs to be primed. Hopefully that answers your question.
Yeah.
ACM, that's a great question. And I've got a couple extra slides on that actually. So ACM, you can have an issue called read-through or telegraphing, or any other terms that people have heard for read-through and telegraphing. When I say that, do you guys know what I mean? Ghosting, anything else? Scrunching, I like that one. That one I haven't heard before. So ACM has thin metal and with a layer of thermoplastic in the middle. So there's 3 things that contribute to read through. And one of them is shrinkage. When the adhesive cures, it shrinks slightly. And when that adhesive shrinks, it's pulling on the surface. And so if you have a bead, you're going to see a line where that adhesive has sucked that metal down. The adhesive's doing its job. It's strong. It's stronger than that thin metal is. So you see a line. It might be very slight, but it's enough that you see a visual distortion. Okay? So shrinkage. The other one is flexibility. If the adhesive is very brittle and doesn't have a lot of movement capability, then it's the adhesive's not going to give, the metal's going to give. So that's another thing is the the shrinkage and the flexibility. And the third thing is exotherm. So when the two components mix, it creates heat. That's what's called an exothermic reaction. You guys have probably, if you guys have ever worked with these materials, you've probably experienced that this stuff gets hot. Sometimes it can get up to over 200 degrees. So if you have an adhesive that has low exotherm, that means it's not going to melt that thermoplastic and cause things to move. So there are adhesives on the market called low read-through adhesives. This is not, I've talked about a couple of specific products. It's not supposed to be salesy, but you guys are asking for information, so I'm giving you answers. That's actually this product I used right here. This is the SignLock 810. This is what's called so a lot of people use the 406. The 810 is a low read-through adhesive, and it solves that problem by addressing those three factors. It has low shrinkage, it has a lower exotherm, it doesn't get quite as hot, and also it has high flexibility, 180% elongation, and a typical acrylic might be 10, 20, 30%. So it's much more flexible. So when that adhesive does shrink a little bit, because it's not zero shrinkage, the adhesive is able to give and expand and not force that line in the metal. So using the right glue for the right application. Now this is a more expensive product. So do you want to, I've talked to sign shops, they just say, I just use A10 on everything. Well, when you have a more flexible product, you actually give up on strength. So you lose a little bit of strength, you gain the flexibility. So do you want that? And do you want to pay for a feature that you don't need if you're buying a really rigid material? So hopefully that answers that question. What was that?
And they don't.
Yes, the A10 is also a slower product, so you're going to lose in production time too. You're talking about maybe a 20-minute open time versus, say a 6-minute open time at room temperature. All right, so we're zeroed again. We've got our stud weld. Let's see, adhesive versus stud weld. Is the stud weld stronger than our strongest adhesive? So we're at 1.1, 1.6, 1.92. Oh, let me show that's not touching. Don't want to break my machine. There we go. All right, we're at 3. Oh, getting to 3. Oh, so we got 2.8. And I'll pass that around. So that tells me, I don't know if you guys come to the same conclusion. One of the questions, especially from the skeptics, is, that'll never hold whatever. So let's pass that around. You can see what we're looking at. And yeah, you might correctly point out, well, hold on a second, that was 1 point compared to a larger surface area on the adhesive. Yes, but that's typical. We're typically doing continuous adhesive comparing to spot welding. And what has more surface area? So that dolly adhesion is just for testing. We also have these things. So you could glue a fastener on, and this has more surface area than that stud weld does. So that tells me, you guys can come to your own conclusions, that you might have more surface area, similar performance, if not greater, and you have the benefit of the speed. Everyone can do it. You don't need special equipment. It doesn't deform anything on the reverse side. So I think that's good for the testing portion. With the time that we have left, anything else that, oh yeah, Mark, you want to come up too? Invite you up. So we'll have we'll open up the Q&A. We've kind of been doing Q&A throughout. I've got Mark Moreski here from Lord Corporation. He's another adhesive expert. And you can feel free to sit in that chair there. You got a mic, you just can flip that on.
Chad, can I ask one more question?
Yes, sir.
So for push through, we give you a lot of that silicone, right?
Yep. Mm-hmm.
You're saying that the Evans polymer would be a better substitute that they fit?
In my opinion, yeah. Yeah, I think it would do the same thing. You'd get more strength, it'd be paintable. And I don't really see a downside other than you might pay $1 more too, which I think in the long run is not super significant. My opinion. You guys come to your own conclusion.
We recommended more, the devil more con. So we still come our LEDs now, our HDM off the HP back to buy that.
Okay.
But mom real well. You have a representative one.
So you're doing ACM to, what was it again?
The LED themselves.
Okay, so you're putting the LEDs on the ACM, and there's tape pre-applied to the LEDs, and you're asking, and you're typically using a silicone to apply that, and you're asking if there's something better. Is the silicone working well for you now?
If you put it on right, like you embedded it, the bar really good.
Yeah. See, that's another example where I say that silicone is not the best tool for the job because silicone takes a long time to cure. And for the first couple hours, you're not at 10% or 30% or 40% or 50%, you're like at 0%. So if somebody comes over and bumps it in the first 2 hours, so if you get an instant grab MS polymer, you know, you can get some strength right there. It's not going to move. You can move the sign around. You don't have to worry about the things, you know, sliding down or whatever. And then another cool product is there's hot melt adhesives. So most people think of hot melt as, oh, a little hobby glue. There's actually high performance hot melts that will actually stick to metal. And that's instant, you know, especially you got hot glue contacting cold metal. If you get a metal bonding hot melt, you know, you get some grab right away. So that's a cool, we have a lot of people that are doing that, and that works well for a lot of people, or just ripping that tape off and getting a better tape. You know, a lot of times they use 3M tape, they're using good stuff, but are they using like which grade of 3M? Because that's a common thing I hear from everybody. I don't know why hope no LED companies are in the audience that aren't happy with me right now, but I'll say what I say, you know, why don't you spring for a little bit of the better tape where people are, because the tapes can do it. I know they can. But anyway, all right, other questions for the Q&A part?
What's the specific layers or you go ahead?
So I got a couple on this table. I'm a little biased, so take it for a grain of salt. We got the Lord 7610 DTM is one product here. That's a really high quality MS polymer. We got this Boabond product. This Boabond is one of those instant grab kind of products. If you Google like instant grab hybrid adhesive, you'll probably find some different ones, but those are two that work. If you Google, you know, good hybrid adhesive or best hybrid adhesive or, you know, so not to take a particular stance, but those are two that I know and trust, and I've seen work time and again, and there's more.
If I can add too, sorry, Andrew, to answer, also to kind of add on to your question about the silicone, I think the silicones have their place, but their average is, I think about 100 PSI. If you were to do the same test here, it ends up to be about 100. I believe ours is the strongest. The Lord 7610 is the strongest in the industry at 550 pounds. So it's not structural. We consider 1,000 pounds structural, but at 550, your LED lights are never going to fall off. To answer your question earlier about scraping it off, one of your question, it's not as easy. Silicone kind of peels right up, and once you get it running, you're going to work to get it off, but it will come off. So
is that clear?
No, it's bright white, non-shrinking, paintable while it's still drying, and non-shrinking and bright white, non-yellowing, UV resistant.
For example, the place to use clear,
Yep. Yep.
I'm not going to feel like something that feels
Right.
So you had mentioned that's clear.
Yep.
Will be used as
Yeah. Compared to, you know, it's just a matter to what degree. So there are clear MS polymers. There's a couple of them out there, and they're pretty good. And they'll be probably as strong or stronger than a clear silicone. But is a clear MS polymer as strong as a not clear MS polymer? No. But I don't think you'd see a difference. You wouldn't see a difference from clear silicone to clear MS polymer.
All right. So just to follow up on that question. So then a clear MS polymer is still stronger than silicone?
In my opinion, yeah. And especially, it's a function of hardness. So the harder the material is, the less flexible it is, the higher tensile and shear strength that you have. So that's the inherent trade-off. The more flexible something is, the more give it has. Now, that's just pure strength. That's not impact. So when you have something that's more flexible, so you want that sweet spot between, if you get something that's too rigid and something comes in and hits it, okay, you've sacrificed some strength, but you've gained some impact resistance. If you have something that's too flexible, then you're not going to have your maximum total strength, but it'll do pretty good if someone's, you know, beating it with a tire iron. Any other questions? Yes, ma'am.
What about the and sort of calibrate the what for their application? How do you kind of that thing different area?
Between surface area and
Like on the whatever the breakdown how wide.
so you're saying, how do you figure out how much glue to use where you're not wasting glue and at the same time you're...
Then she go out like they have 100 gallon flour and you only have one below fence for that fill on the down the
It's per square inch.
Right. So this is a common thing.
30 square inches, there's 30 times 100. So it's multiplied.
Yep. So that's the difference between PSI. Don't confuse PSI and pound force, right? So PSI is pounds per square inch. Pound force is the total amount of force applied to that whole sign or whatever it is. So if you've got 4 spots of adhesive in the 4 corners on a 1x1 sign, if you've got a square inch in each corner, you've got that times 4. So that's your PSI, is your total force, right? So
if it weighed 100 pounds and you've got 4 dots and each one holds 100 pounds, you got 400 pounds per square inch of force holding it to the wall versus 100 pounds trying to pull off, right? If
So
it weighs 100 pounds.
Right, so you have 100 PSI, but 400 pound force. So 400 pounds for that whole sign in that example. So you can do some quick back of the envelope math. If you know what you're on the data sheet, it should tell you for like say aluminum to aluminum or aluminum to steel, what is the shear strength. So typically as signs, you're usually looking at shear. So if you guys don't know the difference, you guys probably know the difference between tensile and shear, but just to clarify, shear is this way and tensile is this way. So maybe if wind catches it, you might be going this way, but often we're fighting gravity, so shear is typically the most relevant number for a sign company. So if you look at the shear values on your adhesive and you know how much square foot of bond you have versus how many square inches of bonded area you have, all you gotta do is multiply that number by that number and you have your total pound force for engineer. And if you had an engineer on a job, they'd probably do the same thing. And add in a safety factor, right? Because if you know that your joint can handle 2,000 pounds. Oh, great, let me put a 2,000 pound sign on. That means once you get to 2,001 pounds, it's on the floor. So you want to have a safety factor. You want to be a hurdle above that. So, I can't tell you what to use as a safety factor, 30%, 50%, engineers to talk about that.
Speaking of engineers, Gail, who Andrew asked a couple questions earlier, just left. So, but you can get a hold of our engineers through our 877 Ask Lord. It's a hotline, extension 4, extension 3. So 877 Ask Lord. Obviously, our numbers are up there as well.
Yes, there's some contact information we had one other person on the panel. Actually, had 2 people on the panel that couldn't make it, but that's okay. So, but you got some contact information if you got questions.